College Algebra, and today we'll be discussing section 4.2, which talks about logarithmic functions. So we start off with the definition of a logarithmic function. So definition of the logarithmic function. So for x greater than 0, for x greater than 0 and b greater than 0 and b not equal to 1, y is equal to log base bx is equivalent to the exponential expression b power y is equal to x. So this is the logarithmic form. And this is the equivalent exponential form. And when we write the function, when we write a function, f of x, when we write a function, f of x is equal to log to the base b of x. This function this is the logarithmic. This is the logarithmic function with base b. So let's use an example to illustrate some of these. So this will be our first example. So this is example 1. And it says, write each equation in its equivalent exponential form. So the first one is 3 is equal to log to the base 7 of x. So in its exponential form, we would write this as 7 power 3 is equal to x. And the second one, 2 is equal to the log of log base b 25. And in this exponential form, write this as b exponent 2 is equal to 25. And the last one, we have log to the base 4 of 26 is equal to y. So in this exponential form, this becomes 4 exponent y is equal to 26. Let's look at another example where we convert the exponential form to the logarithmic form. So example 2. And it says write each equation in its equivalent log form. Okay, so the first one is a raised to power 5 is equal to x. So in this logarithmic form, we have log to the base 2 of x is equal to 5. And the second one, b power 3 is equal to 7. And this log form will be log to the base b, and of 27 is equal to 3. And the last one, exponents exponents of y is equal to 33, and its log form will be log to the base of 33 is equal to y. All right, so this is how we convert from exponential form to a log form. All right, so let's look at some other examples. So this is example 3a. It says evaluate. So it says evaluate. So this is 3a and b. It says evaluate. A is a log to the base 10 of 100. So log to the base 10 of 100 is the same as log to the base 10 of 10 power 2, which is equal to 2, because the exponential form can be written as 10 power 2 is equal to 100. And the second one, log to the base 5 of 1 divided by 125. 125 is the same as, so this is the same as log to the base of 5, 1 divided by 5 power 3. 125 is 5 power 3, which is the same as log to the base 5 of 5 power negative 3. 1 divided by 5 power 3 is the same as 5 power negative 3. And this equals to negative 3 because 5 power negative 3 is equal to 1 divided by 125. All right, so let's look at also example 3c. This is evaluate log to the base 36 of 6. So log to the base 36 of 6. So if we set log to the base of 36 equal to y, then we can write this as 36 power y is equal to 6. And so from here we will know that we know that 36 square root of 36, which is 36 power 1/2, is equal to 6. So this means log to the base 36 of 6 should be equal to 1/2. So y should be 1/2, right? We know that 36 power 1/2 square root of 36 is equal to 6. So if we have 36 power y is equal to 6, then the y should be equal to 1/2. All right. And the last example is example 3D. Let's evaluate log to the base 3 of 7th root of 3. So log to the base 3 of 7th root of 3 is equal to log to the base 3. 7th root of 3 is 3 power 1/7. And this is equal to 1 divided by 7 because 3 power 1/7 is equal to the 7th root of 3. All right. So let's look at some properties of logs. So these are some properties of logs. Let's see some properties of logs. Log base b and index b is equal to 1 because b power 1 is equal to b. And also log to the base b1, log to the any base of 1 is 0 because b power 0 is equal to 1. Any number raised to the exponent 0 is 1. All right, so example 4 says evaluate a log to the base of 9. So log to the base 9 of 9 is equal to 1. Just A and B. Log to the base 8 of 1 is equal to 0. So this is because 9 power 1 is equal to 9. And this is because 8 power 0 is equal to 1. Let's look at some inverse properties of logarithms. For For b greater than 0, and b not equal to 1, log to the base b of b power x is equal to x, and log to the b power log to the base b of x is also equal to x. So these are two important properties. Let's use an example to illustrate them. So this will be our example 5. And it says, evaluate A is log to the base 7 of 7 power 8. So this is equal to 8 because 7 because of the first property, log to the base b of b power x. When the base and the index are the same, then it's just equals to the power. And the second one is 3 power log to the base 3 of 17 is equal to 17 because of the second property, that is log b power log to the base b of x is equal to x. All right, so we are evaluating these two based on the inverse properties, two inverse properties that we just looked at. Next, let's look at how to graph on an exponential function and a logarithmic function on the same graph. So let's say example 6. And this is graph. We're going to graph an exponential function. We're going to graph an exponential function. So graph f of x which is equal to 3x, and g of x equal to the log base 3 of x. All right, so the exponential function x, let's pick some x values and find the corresponding y values. So f of x is equal to 3 power x. So when x is minus 2, f of minus 2 is equal to 3 power negative 2, which is the same as 1/9. When x is equal to -1, f of -1 is equal to 3 power -1, which is the same thing as 1/3. And 0 is equal to 3 power 0, which is the same thing as 1. And when x is 1, f of 1 is the same thing as 3 power 1, which is the same thing as 3. And g of x, let's pick and g of x is equal to the log to the base 3 of x. All right, so you would realize that the exponential function f of x is equal to 3 of x. If we write it as a log form, then it becomes log to the base 3 of x. So what I mean is um, g of x is equal to log to the base 3 of x. This is equivalent to exponential form 3 power y is equal to x. So what this means is that to graph the graph of g of x is equal to log to the base 3 of x, the y values, y values of f of x would become the x values of g of x. The y values, of f of x will become the x values of g of x, because g of x is equal to 3 power y, and f of x is equal to 3 power x. So raising 3 to an exponent, which is the y values for f of x, will become the x values for g of x. So we already found the y values for g of x. So when x is 1/9, the y values would become -2. So the relationship between f of x and g of x is that f of x um, is f of x is the inverse of the g of x. So the x values for f of x becomes the y values for g of x. So 1/9, 1/3, when x is 1/3, y will become -1. We are just picking this from the f of x table, and when x is 1, y becomes 0. When x is 3, y becomes 1. All right, so these are the values for f of x and g of x. So we want to graph these in the same rectangular coordinates. So let's do that on the next page. So we are graphing f of x equal to 3 power x and g of x equal to the log of base 3x in the same rectangular coordinates. The same rectangular coordinate system. So we already have the pair of points for f of x and a pair of points for g of x, so we can graph them as such. So we can graph them as such. So this is 1, 2, 3, 4, 5, 6. And this is the y coordinates, and this is 1, 2, 3, 4, 5. And this is 0. This is -1, -2, -3, -4, -5, and f of x is equal to 3 power x. F of x is 3. Let's graph it first before we put it on. All right, so if we go back to the table of values, to graph f of x when x is -2, y is 1/9. So if x is -2, y is 1/9, it's about this point. When x is -2, y is 1/9, it's about this point. If x is -1, y is about 1/3. It's at this point. And if x is 0, y is 1. It's about this point. And if x is 1, y is 3. If x is 1, y is 3, is about this point. So we can join these points. Right. And the graph of f of x it has a horizontal asymptote. It never touches the x-axis, but although it gets closer and closer to it. So this is f of x, which is equal to 3 power x. And let's graph g of x. So for g of x, when x is 1/9, when x is 1/9, when x is 1/9, y is -2. So when x is when I did not indicate, draw the coordinates of the points on the negative y-axis. So this is -1, -2, -3, -4, -5. So for this one, x is when x is 1/9, y is -2. So when x is 1/9, y is -2. It's about when x is 1/9, y is -2. It's about this point. And when x is, let me use a different color. When x is 1/3, y is -1. So when x is 1/3, y is -1. It's about this point. And when x is 1, y is 0. When x is 1, y is 0 is this point. And then also when x is 3, y is 1. When x is 3, y is 1. It's about this point. So we can join the lines to this also as this. So this is our g of x, which is equal to log to the base 3 of x. All right, so this is how we graph both the logarithmic function and the exponential function on one graph. Now let's look at some characteristics of logarithmic functions. So we're going to look at some characteristics of logarithmic functions. So characteristics of logarithmic. Okay, so let's look at some characteristics of logarithmic functions. Um, so the domain, the domain the domain of f of x is equal to log to the base b of x is from 0 to positive infinity. So the domain of log functions is on the positive axis. From 0 to positive infinity is the domain, and the range of f of x equal to log to the base b of x is from minus infinity to positive infinity. And one additional point, the graphs of f of x equal to the log to the base b of x passes through the points 1, 0, because whenever x is 1, y is 0, because we learned from the properties of logs that log of any base of 1, log to any base of index 1 is 0. So this is so because f of 1 is equal to the log to the base b of 1, which is equal to 0. So whenever the index is 1, regardless of the base, you have the log function equal to 1. So this means the x-intercept is 1, and the y with no y-intercept. So the x, the y when x is equal to 1, y is equal to 0. So the x-intercept is 1, and there is no y-intercept for this graph. So when the x-intercept y is equal to 0. So when y equals to 0, x is equal to 1. So the x-intercept is 1, and there is no y-intercept. No y-intercept. And if b is greater than 1, then f of x is equal to the log of base b x, has a graph that goes to the right, and it's an increasing function. And on the other hand, if 0 is less than b and is less than 1, then f of x is equal to the base b of x, has a graph that goes down that goes down to the right. That goes down to the right, and this is a decreasing function. And also the last point is on asymptotes. The graph of f of x equal to the log base b of x approaches but does not touch the y-axis. Approaches but does not touch the y-axis. Approaches but does not touch the y-axis. The y-axis of x is equal to 0 is the vertical asymptote. Okay, so these are some characteristics of logarithmic functions. Okay. Some additional ones are the logarithmic function, reverses the domain and range of the exponential function. So we found this one, the domain and the exponential function. So we found this when we drew the graph of f of x and g of x, that the domain of the logarithmic function becomes the range of the exponential function, and the range of the exponential function becomes the domain of the logarithmic function. So they both reverse each other. And additionally, the domain of f of x equals to log base b g of x consists of all x for which g of x is greater than 0. So let's use an example to illustrate this. So this will be our example 7. And it says find the domain of f of x equal to the log base 4 of x minus 5. So find the domain of f of x is equal to the log base 4 of x minus 5. So the domain of f of x consists of all x such that x minus 5 is greater than 0, which implies when x is greater than 5, that will be the domain. So the domain will be all positive numbers from 5 to infinity. The domain of f is 5 to infinity. All right, so let's look at an auxiliary example to this. So example 7b, and it says illustrate the domain of f of x equal to the log base 4 of x minus 5. So how do we illustrate this domain on a graph? So the graph of an exponential function, the graph of an exponential, so the generic graph of f of x equal to the log base 4 of x will look something like this. And so x minus 5 means it's been shifted to the right by 5 units. So that will look something like this. So if this is 0, 1, 2, 3, 4, 5. So this graph here will become something like this and has an asymptote as it approaches 5. It has a vertical asymptote as it approaches 5. So the vertical asymptote would be the line x is equal to 5. Yeah. So this would be the graph of f of x is equal to the log base 4 of x minus 5. And has an asymptote at x as x approaches 5. All right, so let's look at some common logarithms. Some common logarithms. All right, so for some common logarithms, um, so the function, so whenever we have a log to the base 10, we typically do not write the base 10. So the function, so the function f of x is equal to log base 10 of x is is usually expressed as f of x is equal to the log base x. So whenever base 10, typically we don't write it. So base 10 is typically log to the base 10 is typically the base 10 is typically not written. So whenever we see a log without a base, we should assume that it's a common logarithm, which means it is to base 10. Okay, so let's look at this example here. And it says let's look at this example. So this example 8. And it says the percentage of adults, heights attained by a boy, who is X, years old, can be modeled by f of x is equal to 29 plus 48.8 log of x plus 1. So we see log of x plus 1. We don't see a base. So that means it's to the base 10, where x represents the boy's age from 5 to 15. And f of x represents the percentage. X represents the percentage of his adult height. Approximately what percentage of his adult height has a boy attained at 10. All right, so the boy's age is modeled by f of x is equal to 29, 48.8 log of x plus 1, where x represents the boy's age. So when the boy's age is 10, that means we'll be finding f of 10. When the boy's age is 10, we're finding f of 10, which is equal to 29 plus 48.8 log of 10 plus 1, which is equal to 29 48.8 and 48.8 and the log of 11, which is approximately 80%. If we find this on our calculator, we'll have approximately 80%. All right, so the next section, the continuation of this section, we'll be looking at properties of logarithms, and we will look at some natural logarithms also, and so we will do that in that video. So we will end this video here. We will continue the remainder of this section in another video.